Hello guys, this is my first video in making English, so since now I apologize for my accent, but I promise I will do my best to be understood. So I hope you guys enjoy the video and let's do it. In 240 before Christ, Eratosthenes for the first time in history estimated the circumference of the entire planet. At high noon on a summer solstice, he noticed that a fixed stick in cyan did not cast any shadow, because the sun was exactly above it. But in Alexandria, the shadow of other sticks showed the sun was the 7 degrees from vertical. Knowing the distance between two locations and knowing that 7 degrees correspond to the 50th part of a circle, Eratosthenes calculated the Earth's circumference and its diameter, missing only 161 kilometers less than what we know today. Look, we are talking about one man that in 2200 years ago managed to realize the Earth curvature with just a stick and his brain. So why there are still some people today who question the real Earth shape or come to believe in the flat Earth model? Today, we know there are four fundamental forces in the nature: gravity, the weak force, electromagnetism, and the strong force. Especially for this video, we're gonna focus on just one of them, gravity, because it's responsible for the Earth's spherical shape. Basically, gravity is the attraction between two objects that have mass or energy. That is, all objects has its gravitational attraction. A valid question for this statement is, if every object has a gravitational attraction, so why when we drop a stone in the air, it's attracted to the floor and not to my body? Well, the answer is simple. What will determine the intensity of gravitational force is the mass density. Summing up, the greater the mass, the greater is the gravitational attraction force. That is, the stone goes to the ground because the Earth's mass is so much larger than our body. Isaac Newton was the first to propose the idea of gravity. He described the gravity as a literal attraction between two objects, but centuries later, Albert Einstein described the gravity not exactly as a force. Instead, it's a consequence of objects being in space-time. For Einstein, the universe is like a mesh, and when supermassive bodies are placed in that mesh, ends up causing deformation. And because of that, all the small objects on the mesh fall towards the center. Later, Einstein's ideas were confirmed with the detection of gravitational waves and the first image of a black hole. Having said that, another valid question is, okay, if every object has a gravitational attraction and the gravity is responsible for the Earth's round shape, so why don't we have a round shape? Well, unlike to what many people think, the gravity force is incredibly weak. As written very intuitively by Marcus Chown, there are several small bodies in our solar system with potato shaped. Today, we estimate a trend between 1500 and 1600 kilometers in diameter for a body to be spherical. Think of it this way. In a hydrogen atom, the gravity force between a proton and its orbiting electron is thousands of trillions and trillion times weaker than the electrical force that make atoms repel each other and make rigid matter. It is not a surprise that an immense number of atoms have to be grouped together before the total gravity overcomes the rigidity of matter. The moons Phobos and Deimos do not contain enough atoms, just like you. And that's the reason you're not round. For gravity to have any considerable effect on the mesh described by Einstein, we need a supermassive body. Like this, we tend to have a round shape. Not everyone in the world can go to space and see with your own eyes the Earth shape. But we don't need to go to space to check the shape of the Earth. We have a beautiful documented images of probes, stations, and astronauts for that. Moreover, we can do some experiments right here on Earth without spending billions of dollars to go into space. One of my favorites was the demonstration of Professor Dan Burns at Los Gator High School. In fact, everyone should watch this video because it's sensational. Dan Burns used the gravity to describe the gravity in a simple and most didactic way possible. I will leave the link in the video description. Here testing zone sticks serve as a great experiment to prove the Earth curvature. But the experiment that I'm going to propose here today is an effect that would totally unfeasible on the flat Earth model. The Coriolis effect. We just need 2 people, a rotating platform, and a ball. Just like MIT scientists did. Watch! Did you guys notice the ball seems like to deviate from the course when the platform is moving? This curvy trajectory in the rotating frame is known as the Coriolis effect. The Earth is wider at the equator line, so it rotates faster on the equator than at the poles. That means if you try to throw a paper plane straight from the equator to your American friend, it will probably go astray. That's because while the paper plane was traveling straight across the sky towards the north, the Earth spun beneath it. This is not magic, this is science. And it's true of the science that we can make projections and predictions for the future. Understand why and how we know the Earth is spherical is a plausible and very interesting discussion to do. But within the academic world, discussing whether the Earth is flat or round is out of question. That we can leave to other people's opinion on Facebook. Because the science really doesn't care for your opinion.